In this video, we are going to discuss section 4.1, which is the data section of the data collection chapter. You may recall when we were discussing the introduction for this unit, we mentioned that a massive amount of our learning objectives are knowing the vocabulary. And that's actually learning objective number one. You must know the terminology for data collection, variables, and measurement. Of course, if you know what measurement is, you have to understand how it gets used in statistics. What kind of tools will we use? Progressing further, one of our main learning objectives is to distinguish between the various methods for data collection, various types of data, and so on and so forth. Recording from yesterday, here's the list of all the vocabulary that you would need, and we extended it further by noting here are the ones that we wrote down at the end of the unit yesterday, or end of the lesson yesterday. We know that data is information. Variables are something that can change from person to person, and we know person doesn't have to necessarily mean like a human. It could be car to car, dog to dog, human to human, just whatever something can go, anything that can change from object to object. We know the individual is the person, the dog, the car, the whatever that we're studying. Categorical, we mentioned, are groups. So categorical and variable are data based on groups. Numerical means numbers, so we had data based on numbers. And we'll pick up from here, continuing to take our notes. Okay, so continuing. Obviously, I don't want to sit down and read the problem to you, so for people watching on the on our YouTube channel, pause it, read it. Well, after going through and reading about this survey and all the different things that they are going to ask teenage girls, please note the observation. All of these are variables because they're going to change from person to person. The area code you live will change from person to person. Your favorite color changes from person to person. How many texts you send, how long you've owned your phone, all of those things will change from person to person, which makes them variables. But only some of them are numerical. So identify the individuals and the numerical variables. Let's start here. And I'm going to use color coding with highlighting just so that I can reduce the amount of writing that I need to do. Of course, you guys working at home or in class are going to actually write the pieces down. So, who are the individuals? The girls. Absolutely, Alex. Suppose 1,845 teenage girls are going to be surveyed. Those are the individuals that we're looking at. And since that's the only group, we've got it. We'll continue and say the numerical variables. Numerical means based on numbers. So, which one of these variables are related to numbers? We'll go to run through the list. Age. Is age a number? Come on, Alex. 16, 17, 18, 19. Those are numbers. Quit being a smart. Come on. Your birth date is the day you were born a number. January 22nd. Is January 22nd a number? 22nd is, but when we start looking at January, it's not. So yes, it's certainly related to age, but when you ask somebody, how old are you? Do you expect a number answer? If you ask somebody, when were you born? Do you expect a number answer? No, you would expect something like January 22nd, 1985, or certainly true. Depending on how they ask that question, they could change pieces. For instance, if they ask, what year were you born? That would be a numerical answer. But if they ask you, what month were you born? Clearly month is not numerical because it's January, February. Even if they say month 1, day 22, well, month 1 still refers to January, a category. Not the number 1, but the category 1. So birthday, although it's related to age, and age is a number, the date of your birth is still going to be a categorical variable. What about race?
Oh,
Area code.
oh, yeah.
North Dakota's area code is 701, a number. But do you remember how I said you have to be careful because some categorical variables are still based and will be numbers that are categories? Well, in North Dakota, when we have area code 701, are we 2 less than area code 703? Okay, so where's area code 703? Does it mean North Dakota is 2 less than Virginia? Just because we are using a number, it doesn't make this a numerical variable. Because when we look at our area code, the entire state, 701, it is a number describing the category of where you live. It wouldn't be any different than we said North Dakota is category A. Virginia is category M. Washington is category H. Rosebud is category HIEPCT4, whatever. But you could give them a piece. Even though we're using a number, it is a number that represents a category, which makes it categorical. A bit tricky, you've got to be careful and watch it. I didn't want crayon, I wanted highlighter. But area code is still based on where you live. It's where you live a number? No, it's just an area where you live. Zip code works the same way, by the way. Zip codes are not numerical data. They're categorical because it's assigned a region. It is a number representation for an area. Area is category. Our next one, though, is a whole lot easier. Number of texts you send per month. The amount of money you'll spend each month. Services you want offered. Nope, that's category. Features you want. Category. Length of time that you've had your cell phone. How many months have you had your cell phone? Clearly a number. Favorite color? Nope. So each of them that we've got highlighted in green are numerical variables, which would mean each of these ones that I'm highlighting now in blue, those are all categorical variables. Continuing forward, looking at measurement. All right, here's some more vocab for us to write down. Variables of interest, kind of straightforward. Informally, your variable of interest is the data that you're looking into. If you are curious about the number of texts a girl sends each month, well, the number that they send each month is the variable of interest. Exactly. Exactly, Alex. So if we want to know if they've got a psycho boyfriend who sends them like a million texts, that's something we'd be curious about. Or if you have somebody who just doesn't like texting at all, and so they send 0 texts. It could happen. I don't buy that one, Sammy, because you're not a teenage girl. Okay, instrument. The instrument is the tool that you're using to measure. For instance, if we were interested in the number of miles you drive each month, what instrument would we use to measure the miles you drive? It's called an odometer. That thing on the dashboard is called an odometer, so your odometer could be the tool. Sticking with the car theme, if you're curious about whether or not your battery is any good, you could use a voltmeter to measure the voltage output of your car battery and see if it's still good. Sammy, you brought up some of the obvious ones that you use from elementary school, like a ruler. Absolutely, it's a tool. A thermometer to measure temperature. A protractor to measure the size of an angle. Basically, whatever you use to take a measurement, that's an instrument. All right, moving downward. Units. Units. Units is just another way of saying label. For instance, if we measure your height, what is your height? All right, Alex said 6'4". 6'4" what? You talking 6 kittens and 4 puppies? No, you mean 6 feet, 4 inches. Inches and feet is the label, therefore it is the unit. Well, if I were to look at you and say my height is 180, obviously I'm not 180. I am not 180 feet tall. I'm not 180 inches tall. My height is 180 centimeters. If we start talking about temperature, if you say, how cold is it outside? You can say, oh, it's 12. 12 what? 12 degrees Fahrenheit, 12 degrees Celsius, 12 Kelvin, 12 what? Yeah, I always like the Kelvin scale. Nobody ever uses it. All right, looking at data. If we are doing some type of a research, if we don't plan our design correctly, our research process could have flaws in it. And those are the things that could go wrong. One of your expectations, or one of my expectations of you, is that you can look at a research and figure out what kinds of mistakes got made. If you have a bad design, can you recognize what kind of mistake you made? Validity. Validity is a good thing. It means that you're actually measuring what you're trying to measure. It seems like a really simple, silly example, but if I ask you, how tall are you? And you tell me 58 kilograms, or if I ask you, how tall are you? And you say 200 pounds, does that make any sense? That's not a valid answer. Validity is when you actually measure what you are trying to or what you really want to measure. If you want to figure out how much teenage girls are on their cell phone, are you actually measuring how much they're on their cell phone? Or if you start asking them questions, are you actually asking them how much they're on Facebook? For instance, if I were curious how many hours per day you spend on Facebook, should I ask you how many hours do you spend on social media? Because social media, you're right, Alex, it's no, because social media is going to include things like Twitter. It would include things like Snapchat or whatever else. If I'm interested only in Facebook, I need to ask you Facebook, not social media. If I phrase my question incorrectly, I create a problem with the validity of my experiment. I have to actually ask questions that target what I really want and not ask something close. The second good thing that might go wrong is an issue with reliability. Okay, I shouldn't use the word get. Reliability means you can trust the results. If you do it over, you're going to get something. We know just because of probability, dumb luck can happen. It's not going to be absolutely perfect, but it should still be close. For example, if I'm curious in our weight, if you get on the scale and it says 200 pounds, and then 5 minutes later you get on the scale and it says 350, what do you think about the scale? Scale's probably broken, because did you really gain 150 pounds in 5 minutes? No. Redea, being as tiny as you are, if we were to have you step on the scale and it said 230, even if we looked at it one time, do you really believe Redea weighs 230 being as tiny as she is? No. Those are potential issues with reliability. If the tools you're using are broken, you can't trust the results. Similarly, if I ask questions that, never mind, I'll look at that one coming up here. Okay, bias is of course negative, and it's something that we need to avoid. Okay. Bias occurs when you have results that are consistently inaccurate. Maybe they're too high, maybe they're too low. All right, so let's look at this as an example. When I weighed myself this morning, I was 197 pounds. All right, thanks. Alex, how much do you actually weigh? 250? Okay, Joe, how much do you weigh? 140? So consider this. My real weight is 197. Alex, you said you were 250. Joe, you're 140. These are the accurate measurements for what we actually weigh. Let's suppose we all go get on one scale, and it tells me my weight is 200, and it says Alex is 253, and Joe is 143. This is an example of bias. Every time we take a measurement, it's giving us accurate results. Every time I step on the scale, it says 200, 200, 200. Every time Joe steps on the scale, 143, 143, 143. So we can rely on that. We can rely on it. We're getting consistent results, and it is valid. A scale is used to measure weight. So we have validity, we have reliability, but there's also bias, because every time we get on the scale, it's telling us we weigh more than we actually do. And of course, we could have it go the other way. If every single time we hop on the scale, it tells us here, we can't trust that either. If it's consistently telling you your weight is less than the reality, that's another source of bias. Well, of course, these are examples of numerical bias. We will also look into categorical bias. For instance, if I look at it and say, what's your favorite color? Red or maroon? Red or maroon? Red or maroon? Red or maroon? Well, if I'm telling you all the time that you have to pick red as your favorite color, that leads you towards saying there's a bias present. You could wind up with consistently inaccurate results just because I'm leading you to pick a particular answer. Let me use a political one. Do you support the killing of babies? Yes or no?
Yes. No, just kidding.
Well, consider that. How many people are going to answer that question yes? Okay. Do you support the killing of babies? Yes or no? Well, the vast majority of people are going to say no. What if I'm using that question to actually mean, do you support a woman's right to choose? You see how that's a biased question? If I phrase the question in such a way that it leads people towards answering a particular way, that's bias. Because there's a very big difference between do you support a woman's right to choose and do you support the killing of babies? Those conjure up two different mental images in a person's mind. And so we do need to phrase our questions so that we're not telling people what answers we want. That's biased. That makes sense, guys? All right, let's continue here. Take a second. Read the problem. So tell me what you think, guys. If we base grades on height, tall people get good grades, short people get bad grades, and Renee is shaking her head at me like, I hate this thing already. Let's discuss the validity. Is this a valid way to measure a person's grades in math?
Yes.
Sammy's saying yes because he's tall, but I'm not going to buy that. I know that you can actually tell that's not fair at all. All right, so our comment. This is an invalid way to measure grades. What would be a valid way to measure your grade in a math class? So what do you think? Where should your grades come from? Grades should be based on, okay, the work you do, accuracy on that work. Sammy's still throwing height out there. We're still rejecting it. But we could look at like exam scores, homework scores, quiz scores, but basically it's your math grade should be based on the math that you're doing. Size of your feet, sure. All right, here's our new grading system. People with the biggest feet get the lowest grades. Okay, so let's continue further. Reliability. Could we accurately trust that this is going to be consistent? Would we have consistency in measuring? Yeah, this actually is reliable. Because if we measure your height today, Radea, we'll get what, 5'3"? And if we measure your height tomorrow, are we going to suddenly get 6 foot? Nope. If we measure your height 2 weeks from now, are we going to get 4 foot? No. Every day we measure, we're going to get the same result over and over and over. And, well, you might grow a little bit, in which case, there you go, you get a little bit better grade. Good job for improving. But this is reliable. Every time we do a measurement, we would get the same result. So, result. So yeah, this is reliable. We could rely on us getting accurate measurements over and over and over. We could repeat the grading scale and trust it. What about bias? Are we going to wind up with consistently inaccurate measurements one way or the other? Okay, so how is this biased? This actually is not a biased way. Yes, it's, to answer your question, Rodea, because it is consistently accurate, we would be able to measure your height over and over and over and get the same results over and over and over. It's reliable. Now, is there a bias here? Is everybody basically, a bias would be if you have like a different system for different people. For instance, if I were to say boys get better grades than girls, I'm trying to think of a good way of phrasing this, so let me pause for a second. What we were discussing, if we make the claim that this is not biased, then we have to say that we're not getting consistently inaccurate results. Well, we're not going to wind up with a spot getting people consistently too tall or consistently too low, but we do have a potential bias in gender. Because girls, in general, are shorter than guys, we do have a consistent inaccuracy there. This is biased because girls will be shorter than boys. Shorter than boys. And because the girls are consistently shorter than the boys, it means they get a consistently lower grade, which is a consistent inaccuracy. Consistently inaccurate grades. So we're noting that a study can have good qualities. This is reliable, but that doesn't make it good. Just because something has good qualities doesn't make it good. And just because something has one bad quality doesn't instantly mean it's completely terrible. We'd have to look at it and say, overall, is it worth using, yes or no? Okay. One last part to pay attention to and to look out for. We'll look at this part, we'll do an example, and then we'll quit for today. You have to be careful about rates versus counts. Remember, rates are things like percentages. Counts are the raw numbers. For instance, if I ask you how many people own a gun in North Dakota, North Dakota has, what, 750,000 people in it? All right, now let's go ask the question. How many people own a gun in Russia? In Russia, they have, I don't know the population of Russia. How many millions of people live in Russia? All right, so let's use something a little bit closer. How many people own a gun in Canada? How many people own a gun in California? How many people own a gun in Texas? Well, North Dakota has 750,000 people. And when we look at Texas, Texas has what, about 40 million people? Is it fair to compare 750,000 people to 40 million people, just in terms of raw numbers? Because even if we had 100% every single person in North Dakota owning a gun, if 1% of people in, if 2% of people in Texas owned a gun, they'd still beat us in terms of raw numbers. It's not fair to compare a small population versus a large population. In that instance, we could compare the rates. Not how many people, but what percent of people. It is always fair to compare percentages. It's not always fair to compare counts. So consider this for our last example. Luigi got a pair of jeans that are normally $64.95 for $52.50. Javier paid $48.75 for jeans that normally cost $58.75. Which jeans had a higher discount? Well, consider this. $64.95, and they got them for $52.50. In the first one, they saved $12.45. For the second one, that normally costs $58.25, paid $48.75, and so we wind up with $9.50 saved. Who got the better deal? The guy on the left obviously saved more money, but he saved more money on something that cost a lot more. He was going to buy a pair of $65 jeans. The other guy was going to buy a $58 pair of jeans. In order to compare who got the better deal, it's unfair to look at the raw dollar amount saved. And instead, we should look at the percentages. On this one, and I would like you guys to grab your calculators so we can speed up some number crunching. I don't have mine with me. $12.45 out of $64.95 will tell us the percentage that they saved. Using your calculator, what did you get? Sammy gave me 0.190, which then is 19%. What is it? Okay. I had it backwards.
191.
Okay, so Sammy, you said it's 191, so it's 19.1% saved. Okay, now we'll look at Javier. Javier saved $9.50 out of the price of $48.25. I'm sorry, $58.25. So how much did he save here? $0.163. So he saved 16.3%. So overall, who got the better deal? Guy on the left, both ways. He saved more in terms of the raw dollar amount, and because he had a higher percentage saved, it was better either way you look at it. In terms of raw dollars or percent saved, he beat him out. And we will stop here for today, pick up and continue further. I would like to note a couple things. We're not completely finished, but you should start on the homework assignment this weekend. We have not discussed all components that you need. We'll finish up some of this Monday.